All right, today we're going to be talking about adding and subtracting mixed numbers. So you've already gone over adding and subtracting regular fractions. The most important thing that we need to know when adding and subtracting fractions, if the denominator is not the same, is we have to do what? Make it the same. We have to find a, what do we call it? Find a common denominator. Okay, so same rules apply whenever you're doing mixed numbers as well. Okay, so if the denominators are unlike, the first thing that we want to do is find the LCM of each denominator, least common multiple, to identify the least common denominator. So if I'm looking at this problem over here, it says 8 1/4 plus 2 4/5. Okay, my denominators are different, so I want to go ahead and find the LCM of both. So I'm going to list out my multiples of 4. And I'm going to list out some multiples of 5. And I can already see that I have the least common multiple, which is 20. So now I'm going to rewrite both of those fractions with 20 as my denominator. Now, another thing that you can do is you can look at your denominators and you can multiply your denominators together to get a common denominator, but it won't guarantee it's always the least common denominator. So sometimes if you multiply your denominators together, they will always be a common denominator, but it just might not be the LCD. Okay, so if you're finding the LCM, we've now identified it as 20. I'm going to rewrite both of my fraction pieces of my mixed numbers out of a fraction of 20. So I've got, oh, sorry, I wrote that in the wrong spot. It goes here. So what do I multiply 4 by to equal 20? 5. So I'm going to put 5 here. And if I do it to the bottom, I have to do the same thing to the top. So my numerator of my new fraction should be 5. Because if I do 4 times 5 to get 20, then I got to do 1 times 5 to get my numerator. Okay, now I look at my second fraction, the 4/5. What do I multiply 5 by to get 20? 4. So I do the same thing to the top. So 4 times 4 is 16. Okay, so these are my two fraction pieces. I'm going to move them down next to my whole numbers now. So I have 8 and 5/20 plus 2 and 16/20. So I have rewritten my fractions. So I took this, and now I have this problem after I've done all of the in-between, okay? All right, so now that I've rewritten my equation, I'm going to add my whole numbers together. So I have 8 plus 2, which is 10. Now I'm going to add my numerators together. So 5 plus 16 equals 21. And then do I do anything with the denominator? Nope, it stays the same. Okay, but the problem that I have is that my fraction piece is improper. So now I've got to go to step 6. It says for improper fractions, convert or decompose, which means break apart. So I'm going to break apart 21/20. I'm going to bring that down here. And what I'm really going to do is I'm going to pull out a whole. So what fraction represents a whole? 20/20, which represents one whole, which leaves me with what left over? 1/20. That's exactly right. So when I'm decomposing that, I'm pulling out a whole, however many wholes I can. In this case, it's just one whole. Okay, because I had 21/20. So it's basically like converting that to a mixed number. What is 21/20 as a mixed number if I wrote it that way? It would be 1 and 1/20. When I say decompose, I am splitting it apart. I'm pulling out the one whole. Why do you think I would pull out the one whole? And why do you think there's a little squiggle line here?
Because you have to take the 10 and not the 1.
Yeah, I've got to take my 10 and I got to add it to the one whole that I pulled out of my mixed number, that improper fraction piece. So I'm actually combining 10 and that 1. So my real whole number and my answer will be 11. And then my leftover part of my mixed number, 1 and 1/20th, the fraction piece, 1/20th, is what I attach to my new whole number. So my final answer is 11 and 1/20th. And then what does step 8 say? So there's no questions. Simplify if needed. When in doubt, reduce. When in doubt, just reduce. Okay? I'm not going to count it wrong if you reduce it. So just reduce it. Because it's better to reduce than not. Okay? All right. Do we want to do a subtraction example?
No.
It's the same thing, except instead of adding everything, I would just subtract it.
Yeah.
Okay. All right.